Today, we are going to delve into the fascinating world of data science and explore how R, as a language, a very powerful language, empowers us to unravel insights from complex data. Let's begin. So let's understand what are we going to study today. Our content for today is going to be the very basic introduction to R. Then we'll set up R and RStudio, the very two basic technologies we need to understand and work with R. We'll also understand basics of R programming. We'll work with its few packages. We'll learn how we can import data. We'll do a little bit of analysis like mean, median, mode, and standard deviation. And in last, we'll conclude our all the learning, and we'll also understand from what are the sources we can get more information about R. We can create proper working analyzing projects on R. So let us begin with the very basic thing, that is history of R. So back in 1993, two brilliant minds, Rosie Haka and Robert Gentleman, gave birth to R at the University of Auckland. They aimed to create an open source environment that could handle statistical analysis and graphics with finis. So little did they know this would mark the inception of R, which has grown into an essential tool for data scientists worldwide. Now, fast forward to today. R is like a superhero in the data science landscape. It is a very versatile language and it helps us into the heaps of data to get meaningful insights. Now think of it as a magic wand that turns raw numbers into understandable stories. So why does it matter? Well, in a data-driven world, understanding and using data is very crucial. Now that is where R comes in, helping us to analyze data, find patterns, make smart decisions. So let us explore how it actually works. We'll also read and understand how R's growth in data science is very something we need to focus on. So we'll look at directly the importance in data science. What is R's importance in data science? So let us understand what is data science. Data science is the magic that happens when you blend statistics, programming, and domain knowledge to uncover valuable insights. Mind it, statistics, programming, and domain knowledge. So it is very crucial because data is everywhere, and without proper analysis, it's just noise. What is noise? Lot of different type of noise is present everywhere. Now when we take that noise, structure it in a proper way, take a little bits of noise from everywhere, and we get something we call music. The same is with this. We have data everywhere in the world, but in a very unanalyzed, unproper way. What we can do is we can take that data, put it in a specific format, get insights out of it, get information out of it, and we can use those information for future predictions and future things, and to get more knowledge about something. So this is where our science, with its diverse set of functions, libraries, and community support, R is like a toolkit that helps us analyze, visualize, and extract meaningful patterns from the data. Now, it is our key to make informed decisions and driving innovation. Okay, so theory part is done. Now, let's understand how we can set up R and RStudio. So first, what we'll do is we'll install R. How? You just need to go to the CRAN website, cran.r-project.org. The website is here. This is the official R website. You can go there. It's available for Windows, Mac OS, Linux. It's available for every other operating system. You just have to follow the installation prompts and you will have R up and running. So I don't think we need to see and proper understand how we can go through the installation process. That is very easy and simple, like any other programming language you will install. After installing your language, your R GUI will look something like this. This is R GUI of 32-bit. Now that we have R, we need an environment to work in. Now that is where RStudio comes in. It's like our control center for coding, analysis, and visualization. So it does not end with installing R. You need to install RStudio as well. and it comes with something like script editor, console, various panes where that we will look in future. Let's explore RStudio. What is RStudio, how it works, how we can use RStudio. So it comes with a script editor, it comes with a console. You can see the console right here. It comes with a console and various panes, and RStudio actually provides a very seamless experience for both beginners and experienced users. So let us see and understand what are the contents we get in RStudio. So what we get is a script editor, a console. Now in a script editor, we basically just write and edit our code. In console, that is right here, we write our code, we execute our commands, we should say, and we get real time and instant feedback. Then there is this environment viewer which helps us to keep track of our variables and the plots and files and the packages and the panes. Like it helps us keep tracks of all these things. It is easy for navigation and management. It helps us in all this management and navigation stuff. So these are the environment, these are the types of environment, these are the things that RStudio actually provides us. So it is more helping in terms when we are working with a large data set, which it is very helping. So let us understand very basics of our programming language, that is data types. Now what are data types? They are the building blocks of any programming language. So in R we have data types like vectors, and we have single dimensional data that we call vectors, we have multi-dimensional data that we call matrices, we have tabular data that we call data frames, we have lists for collection of various objects, and all these data types helps us organize and manipulate data very efficiently. Now let us understand how we can write and work in data. R's basic GUI of 32-bit, and we are going to create some basic data types. We are going to work with basic data types, and we are going to understand how they work. So you and I, we both get familiar with the GUI. So let's create something like V. That means let's create a string. Let's create a string that says hello. Now what we can do is we can print that string using the print function, and we will get hello back. Now what is hello? Hello is a character. Now we have some basic data types like logical, that is true or false, a numeric one that is 12.3, 22.5, numbers like this. We have integers that is 24 lakh, 4 lakh, 39 lakh, like very large number of integers can also be included. We have complex numbers, we have character, we have raw. Now how we can know what type of something is? So we can use something like print. We can use a function that is named class. Now inside that class, if I put the variable v, I'll get the output as character because hello is a character. And we can use this function class for every other data type. Now we'll see some more informed data types like vector. How we can define a vector? So when you want to create a vector with more than one element, we should use the function that is C. Now with C function, we can define various things combined into a vector. Let's see how we can write a vector. Okay. So let's for example take a variable named apple. What are the colors apple comes in? Apple comes in various colors, that is red, yellow and green. So let us define red, yellow and green characters inside an apple. We'll use a C function. We'll write down red, then we'll write down green, and then we'll write down yellow. Now after this, if we print apple, we'll get something like this. And if we want to know the type of apple is, it will show us character. See, because the contents inside that vector that is apple is character. Now we also have something we call lists. Just imagine we have a list called L1 that that carries something, that carries multiple things. Now, what is different between a vector and list? A vector will contain similar data types. We cannot put red 1 and assign value inside a vector, but we can do that inside a list. We can also put a vector inside a list. Let's see how we can do that. We define list using the keyword, using the function list, and let's define a vector inside list. Let's say C. That's how we define a vector. We have 1, 2, 3 inside C, and now we are defining that is the single element of list. The second element of list can be something like 21.3, and the third element can be something else like sign. And let's save it this way, no errors, and let's print list simply L1. See, we got our list here. Now next we can define matrices. Now with matrices, simply we use the keyword matrix. Let's define a matrices with the variable m. How we save it? We save it like this. So matrices, no, matrix. This is what you need to use, matrix. Matrix C. We can put something like so matrix is like the simple matrix that we use, like matrix and determinants that we understand in maths. It is same. So how we will define it? We install a vector inside a matrix first. Let's see how we can do that. We do that like this. We use A, we need to put as much as characters we want to have in our matrix. I want my matrix to be 2 by 3 matrix. So for the 2 by 3 matrix, I need 6 elements. So let's put 6 elements in our matrix. This is the elements that we have defined. Now we need to define the number of row that is going to be going to be 2, number of column and col that is going to be 3, and then we are saying it to save it by row. We are saying it to save it by row, so that makes it a true. This is how we have saved our matrix. Now let's try printing our matrix M. See, it is that easy. Now in the similar way, we can define arrays, we can define data frames. Now data frames are what? Data frames are tabular data objects. Unlike a matrix in data frame, each column can contain different modes of data. How? The very first column can be numeric, the second column can be character, and the third column can be logical, true or false. It is like a list of vectors of equal length. That is the basic difference between a data frame and matrix. We cannot save number and an object and a vector inside a matrix. So let's see how we can define a data frame inside our programming language. So data frame, as I said, data frames are different than matrices. Data frames in which we can save different values in different columns. We don't need to bother about that. How we can define a data frame? We can define a data frame like this. We can define data frame name detail that says data.frame. Data.frame is the function that we use to define a data frame, create a data frame to be precise. Now we are defining gender. We are providing gender vector. Gender is a vector of characters. So it has male, female, male. Now it has another object named height. Now height is a vector again, but of numeric data type 170, 152 and 180 centimeters. Now we are just using these two information and we are going to print a detail. If we are going to print a detail, we are going to get something like gender and height in a tabular format, in the same way how we entered them, in a very respective manner. So this is how data frames work. Now let's get back into our presentation. So far we understood our data types. We understood something like numerical, integer, character, logical. We saw and we worked with vectors. We created matrices. We also created data frames. And we obviously know about array, just simple multidimensional array. We also created lists. Now we'll look at basic operations. Now, R's beauty lies in its ability to perform operations on entire dataset at once. We need to add, subtract, multiply, or delete. Now, R's vectorized operation make it a breeze, allowing us to perform calculation very efficiently and very easily. So yes, basic operations we have here like plus, minus, multiplication, and division. Now, variables, assignments, and basic functions. What are variables? Variables help us store data for very easy access. So we assign variables using the operator this. We assign our variables using this operator, and when it comes to calculation, R comes very packed. Like we have mean, sum, length, square root. We have this to perform further more calculations. We can create our own functions for customized tasks. So think of it R like language of its own vocabulary. We have different type of words in R, and these words are data types. We have scalar, vector, matrices, data frames, list, and then we have basic operations, and then we have variables, assignment operator, and some basic functions available to us already. So let us go more deep into R. Let us understand how R works. So now we have come to the very main part of our explanation, that is data manipulation with dplyr. I personally pronounce it dplyr package. Now D stands for data frame, that we recently understood how to create one and how it actually looks like after printing. And plyr stands for pliers, so which is referred to as tool to manipulate data frame. You can think of dplyr as something like Swiss Army knife for data manipulation. What is it? It is part of the tidyverse. What is tidyverse? It is a suite of packages that is designed to make data work very cleaner and very more intuitive, I should say. Now, dplyr simplifies tasks like filtering, summarizing, transforming data, and many much. So it makes the lives of data scientists very easy. This is basically used for data manipulation, as I've said here. How we can install it? Basically, we just need to install it using install.packages function. We need to write dplyr in a quotes, and after, instead of installing this only, we can install the package name tidyverse, which includes dplyr inside it as well. So you can use both of the process. You can either do this or do this, and you will easily install your dplyr package that we are going to work in future. So after installing, you need to load the libraries. You need to load the libraries of dplyr. So with dplyr, we have set of core verbs that act as our go-to tools. We can select columns with select. We can filter rows. We are going to learn all of them in further upcoming slides. So let us go through them. We have, I'm definitely sure you have installed your packages and all the libraries. You have loaded the libraries as well while I am talking, because this is how we are going to learn. I am going to show you how to write the code, and you are going to perform them as well as side by side while watching the video, so we can both learn and practice at the same time, because definitely a programming needs practice. So this is how we create a data frame that we have learned. This is a much larger data frame than what we created, but this is the same. We are using the data.frame function. We are giving it ID, we have names, we have gender, we have date of birth. We are also using the function as date to save is in a date manner. We have two values as well, not available, NA values, and we have row dot names that will give R1, R2, R3, and we are naming that data frame as df. This is our assignment operator, and the output after printing that df will be something like this. This is our output. Now we are going to work with the few functions that come up with dplyr packages. Those few functions are select, arrange, summarize, etc. So let's go with the very first one, that is select. So now we are going to understand what select does. Now select is used to select the columns or variables from data frame. How it does? We tell select what is the data frame that we are going to work with, like this, and then we tell select how to select, like in what parameters it needs to select the data frame from, the details from. So our data frame we have defined here is T. We are using select function to print only HT data. We are using this HT data only. So something that starts only with HT, we are going to print that only. Then here we are telling select details from data frame D, and that starts not with HT. Like except for HT, we are using minus here. That does the work of removing. It is like we are saying it to not start something with HT, print those only. Then we are saying to select from column 1 to 2. Then we are saying to print headings that contains A. So this is different ways we can use the select function that comes with dplyr package that we can use to access the data frame and later on do manipulation with it, or select the data and take the data as we want. So for the given programs, we are getting output like this. Here we are getting only HT. Here we are getting that does not has HT. Here we are getting the details we asked for. A 4 into 2 table means we are getting 4 rows and 2 columns only. Now we'll see filter. Now what filter function does it is used to create a subset with matching logical conditions. Filter is same. We use filter as the word says. We filter data and take insights from data as we want. Like is not a HT, so we will use HT with NA values, and it is with no HT, like we'll find the rows with no NA value, and the output of the given functions will something like this. We'll get this with NA values only, and we'll get this with no NA values. HT with has NA values only, and HT with does not has NA values. So this is how we filter data. This is our complete data frame, and these are the two filter outputs that we are getting here. And the best part is with select and filter, we can only see data. We can only see data in a specific manner that we want. Now we can also save them using a few functions like mutate. Now what mutate and transmutate does, it is like addition of new variables which are the function of prevailing variables. How it works? Let's see. With mutate, we want to calculate a variable x3, which is sum of height and age of printing with HT and age. So HT and age, we are creating a variable named x3, and we are going to get a table out of it. The same goes with transmutate. We are calculating a variable x3 again, which is sum of height and age, and printing it without HT and age. And this will print it with HT and age. Let's see the output. So this is how the output is going to be. The first output was mutate, which was going to print it with HT and age. So we have HT and age, both of them here, and x3 variable as well. So it is like 46 plus 7, that is 53, NA plus 5, that is NA, NA plus 9, that is NA, and 69 plus 16, that gives us 85. Here, transmutate will not print HT and age together. So we are going to get the value x3 only, 53, NA, NA, 85. Both are going to give us the same output for the same code, but we are not going to get this two extra information in transmutate. This is what mutate and transmutate does. As the word says, it mutates the data frame into something that we have asked for. It delivers us a mutated version of the data frame. Now let's see arrange. Arrange, as the word suggests, it is for reordering of the cases. Now how we want to arrange is how we are going to tell it. Now for arrange, we are going to save arrange into a word, into a parameter, a variable named d name. We are going to tell arrange that we want to use the data frame d that is defined here. So we are going to tell the arrange function what are the parameters we want and how to arrange the data frame in our way. So first of all, as I said, we are saving the arrange in d.name. We are telling it that we need this d data frame to work with, and we are asking it to arrange in terms of age. Now we are not providing any other extra information, so it will put it in terms of age. Let's see how. It is the very first name was Abhi, then Bhavesh, but now we are getting it in terms of age. That is Bhavesh first because he has lowest number of age, and then we'll get Abhi, then we'll get Chaman and Dimri. So this is Bhavesh, Abhi, Chaman, Dimri arranged in terms of age. This is how we can arrange. This is all data manipulation that we are doing. This is very small amount of data that we are using for manipulation, but this small things, we can use the same things in very large big data sets. Just imagine when we want a data set to be arranged in a specific manner, we can do that just by using a function named arrange that we have installed in dplyr package. So these small functions are going to be very valuable in our future inside our future manipulation processes. So this was your introduction to arrange. Now we'll see summarize. Summarize, it condenses various values to one value. How? Let's see. We are using summarize function. Again, we are telling it to use the D data frame that we have defined here. We are asking it to use mean. Now we want a mean value of age, and we are giving it a variable named mean. The same we are doing it for minimum of age. The same we are doing it for max of age. The highest age the one has, that is Dimri, and we are using it for median as well. You can see we are using the same variable here and here and here as well. That does not matter because the variable won't exist outside of the summarize function. So every time outside of the summarize function, this variable is not existing. So you can use similar variables inside a function every time you are using that function. Let's see the output. You are getting a mean of 9.25 based on age, a minimum of 5, that is the lowest age we have here. Then, as I said, highest age, that is of Dimri, 16, and then a median age, that is 8, that is of no one's. Yes. So this is how you are getting a summarized value, that is a summary. You don't want to print a table, you want a summary. That's what you're getting here. Now let's see a very important but something we are not going to use much in our course right now, that is piping. Water piping, these are basically a way to chain multiple operations together. Just imagine in maths what we do. We create a function of x, that is function of g, that is function of h, that is function of something other like y, and if we want this, we put all of them into curly braces or brackets. How we can do this here? We can use the chaining commands like this. So now there are two chaining commands. One is this and other is this. There are two chaining operators. This operator takes the output of the expression on its left and it passes it as the first argument to the function on its right. That is, it takes the expression from the left and passes it to the first argument on the right. And this operator does the same thing, but it also updates the value on the left side of the pipe in the place. So this operator, the very first operator, does not update the value, but the second operator updates the value. Hence we are using two signs here. Again, I am saying pipes are for what? Pipes are a way to chain multiple operations together. How? Let's see in the example in the upcoming slides. So here we want to call one function and then pass its result that I just said, function of x, to another variable, another function. And that is very easy. Like we have function of x, we can write it as x, the pipe command operator, and function. We can write it as function of x is function of g, that is function of h. We can define it like x, that is function of f, that is function of g, that is function of h. This is very easy because using this kind of commands in our function makes it very hard for a coder to understand. But if we want a coder to understand what we are writing and to write a very efficient and nice code, we write it in this manner. This is very easy to understand, easy to write, and for someone else who's not a coder or who is new to the code someone else has written, it makes it easy to chain multiple commands together and for them to understand as well. So this was our introduction to piping for chaining commands. You can use this and explore it more in Project Pro and other analysis and another processes that you are going to go through, but right now we are not going to use it much because for a single video where you are just learning about R, that is going to be very confusing. So we are just going to stick to the very basics, and you will learn more about it in Project Pro proper projects that it's going to tell you about. So let's understand what is ggplot2. This is, again, we have been through manipulation. Now what we have done, we have selected, we have filtered, we have arranged, we have analyzed, we have summarized. We were going through the process of manipulation. Now we want visualization. What visualization means? It's like turning numbers into stories. How? How we can visualize data? We visualize data through bars, histogram, charts, pies, whatnot. So ggplot2 is again our artistic tool that transforms raw data into captivating visual narratives. That is, simply we are going to create histograms, bar plots, graphs, whatnot. This is going to be very interesting because when you want to get insights from data, the very first thing that we think of is visualization. Mean median mode is the very basic thing that we went through and we are going to see again in our upcoming slides. But visualization is very important because that is how we see our data and analyze it. So ggplot2 is basically a package that was designed by Handley Wigman, and it follows the principle of grammars of graphics. What is grammar of graphics? That is an approach that breaks down the plot into components. We have very different components. That is also can be seen as processes. How we define our data for visualization. Now, you definitely need to install ggplot2 package into your RStudio and R so you can use it efficiently. I am definitely sure you will install it using install.packages and inside the bracket under quotes ggplot2, and you will install all the libraries that is needed using the library function. So now let us see the building blocks of ggplot2. That very first block is data. See, data is the very first block here. What data does is data is something we tell. We tell it about the data itself. Like in the previous programs, we were telling select that we are going to use this specific data frame. Here we tell ggplot2 which data we are going to use. Then we have something called aesthetics. That is, we map the data into aesthetics like x-axis, y-axis. We color it, we size it, we label it, we shape it. Then we have something called geometrics, like how our data being displayed using point, line, histogram. This is where we choose what kind of display we want. Then we have something called facets, we have statistics, we have coordinates, we have themes. Now this is in the same manner like this. First we have data. We define the data we want, the imported or already present data that we want to work with. Then we tell it aesthetics, like how x and y axis are going to work, what are they going to be called, how are they going to work. Then we have geometric objects that actually define how our data is going to be look like, how it's going to be, how we will visualize it. Is it going to be a bar graph? Is it going to be a histogram? Is it going to be a bar chart? Then we have facets, statistical transformations. All this extra information are going to be too much and overwhelming for someone who is learning them in first. So we are going to go through these three things only: geometric object, aesthetics, and data. Let's go through them. So aesthetics are aesthetic mappings, and we use AES as function. Now what it does, again, it maps variables. What it does, it maps the variables in the dataset to visual properties like color, size, and shape, and it bridges the data to visual attributes. What do I mean by bridges it? It tells which column and which column belongs to which uh, coordinate. Like we have two coordinates, one is x, one is y. We have one x coordinate right here, and one we have y coordinate right here. So it tells which coordinate, which column belongs to which coordinate. That is what aesthetic mapping does. We map the variables to a dataset. Now what geometric object does is we use this function named geom underscore star. Now this star is not there actually in the function. When we are using this star, we are changing the value of star to some another variable. That could be histogram, that can be point, where we are defining different types of different types. So we can differently we can visualize or we can show our data that is written, how data is represented visually. So let's see them in some more defined manner. This is the data layer that we were discussing about. This is the data layer. So here we are first of all importing all the libraries of ggplot2 and dplayer package because we want to use both of them. Then we use this one basic function ggplot that defines the visualization and that defines the actual visualization. Then we are using data is equal to empty cars. Now here again we are defining that we are going to use this empty cars data set. Then we have labs that defines title. That is, this title is going to be in front of our, like in the very upper corner of our plot, that will name our complete plot or complete bar as mcars data plot. This is data layer where we define from where it should take data. The data is empty cars. That is already defined in ggplot2. That is sample data that is already present there. Then we have this aesthetic layer. This aesthetic layer does is it defines that x is going to have HP column values and y is going to have MPG column values. HP and MPG are the columns that are present in empty cars, and HP is assigned to x and MPG is assigned to y. Now we are saying that column is equal to display, this is equal to display. Then we have labs. We are giving the title empty cars data plot to our plot. Let's see how this is going to look like. This is the output. This is how it's going to look like. So this is the title that we recently just gave, empty cars data plot. We have MPG in y section, in y coordinate. We have HP in x coordinate, and this is our plot. That is how we define aesthetic layer. Now we'll understand how actually, but this is not a graph or plot. We are just defining the values here. How we are visualizing it is going to be in the next part, that is geometric layer. In this layer will define how our data should be displayed, how our data being displayed. Now we can use point, line, histogram, bar, box plot for each specific type. We are using geom underscore point to show points designs, or we can say scatter plot typed visualization. We are using ggplot, that is the function. Data is equal to empty cars. Data layer, we are defining empty cars is the data set that we are going to work with. AES for aesthetic, where we are telling HP is our x coordinate, MPG column is our y coordinate, column is equal to display. Geom point is telling that our visualization, that our display is going to be like point wise scatter plot. Title is miles per gallon versus horsepower, where x name is horsepower and y coordinate name is miles per gallon. Let's see how it will look like. It will look like this. Miles per gallon, we named it. Horsepower, we named it. Miles per gallon versus horsepower, we named it inside title. And this is how it's going to look like. And this is the column display that we showed earlier. We can change the color from blue to green to yellow to red. We can change the design. We can change the outlook. But this is how it's going to look like when we are going to use geom_point. This is how it's going to look like. Now let us see how a basic scatter plot is going to look like. So we are using ggplot. We are using the iris dataset. With aesthetic, we have told the sepal length and the petal length. That is x-axis or y-axis, and then we are a plus sign, we are saying it geom_point, which is going to say that this is a scatter plot, and this is the output that we are going to get. This is the petal length, this is the sepal length. We have named it when we are using geom point for telling that we are going to get a scatter plot out of it. We can use this, we can use or add more functions inside, but we are going to keep it very simple and just create a simple plot. Hope you are also doing the same thing, the same code in your code editor out there and practicing it as line by line with me. Let's see histogram. We all know what is histogram. We can create histogram using geom_histogram function. How we are going to do it? We are going to use ggplot. This is the code. This is the code that we are using. So we are going to use ggplot, the function data is equal to mpg. Mpg is our data set. AES aesthetic, x is equal to HWY. HWY is the column that is present. Now we are just defining that x-axis, the x coordinate. We are not defining the y coordinate here. Okay, fine. Again, we are defining the histogram color red, fill it with green, alpha should be 2 and bin width should be 5. We are defining the design of our histogram. We are literally writing here geom_histogram. It includes all the necessary attributes for creating a histogram. It takes the attribute of HWY with respective count. Color is taken as per the requirements, that is red and green. So this is how it's going to look like. So here the color is not visible for some reason, but in general the color would be visible as red and green to all of you when you will run it in your code editor. Please do try it and tell me in the comment section. Let's see one again, bar chart. How bar chart is going to be? We will use geom_bar function to define a bar chart. How? We add ggplot to a name called p. Now p is the variable where we are saving this. Again, ggplot. mpg is the data set that we are working on. AES is aesthetic. We are telling it it's a class. Class is the name of our x-axis, name of the column that is present in mpg. Then we are telling it geom_bar that we want a bar chart, and this is the outcome, this is the output that we are going to get. That is how we can create a histogram or bar chart or a pie chart, whatever type of visualization, whatever type of design or visualization we want with our ggplot2. It's written ggplot2 offers flexibility in customization. We can definitely customize it as our requirements. The columns we want to use, the columns we don't want to include, the type of color we want, the type of design we want. It offers a lot level of flexibility. Then we can also change colors, we can label, we can give titles. Like we can do a lot, we can tailor a lot to its visual appearance. And again, themes can be applied globally to maintain consistency across visualizations. Like we can define a specific type of color, design, a few specific specifications, and then we'll use those global specification into the same histogram, same bar chart, same pie chart. So if a column is colored blue, Then the column will be colored blue in the histogram as well, in pie chart as well, in bar chart as well. That single column will be colored same in all other visualizations. That is what we are trying to say, to maintain a global consistency across all visualizations. That is how we theme it. That is some other another level topic that we'll discuss later. Currently our basics is going to be just R and how we can explore using R. So let's understand data importing. So see, data, now that we have analyzed and visualized data, how about we learn how to bring new data? You are not going to create all the time data frames for your data. Data comes in various formats and CSV files are one of the most common. We can use read.csv function to import CSV files as data frames, which are easy to work with R. So we have worked with analyzing, we have worked with visualization. Now we want to import data from outside. The very common one is CSV file. We use a CSV file and we are going to use this read.csv function for importing data. You have to do nothing. You just have to import the required libraries and use read.csv function, that reads comma separated values CSV, and you can load them into R as data frames. Remember, they are going to be loaded into R as data frames, not just in tabular manner. So you have to treat them as data frames. This is how we are going to do that. We are using CSV underscore data as variable because data frames need a variable to be saved. Then we are going to use read.csv where file is equal to sample.csv. It is going to be under quotation. And now if we are going to print CSV underscore data, we will get the head. Head means 6 into 6 or some already defined number of columns and rows that we will see, the head of data. Now if we want the number of columns, you will use ncol as function. Ncol is a function already defined in R. You can use to get number of columns present in the data and nrow to get number of rows present in the data. They both will give you a single number output, be it how number of columns it has, number of rows it has. If it has no columns, it will give you 0. That is very unlikely. So now we will import Excel files. Excel files, see, generally our data is stored in CSV files, but sometimes the data is in Excel sheet and you want to import that. So read Excel. It helps us read Excel files seamlessly. And if you are dealing with databases, you can use DBI or as RSQL Lite to enable to connect database. So for Excel files, nothing, just install the package read Excel. Load the package using library read Excel and import it into a value data1 and data2. And what are these? These are again data frames. We are importing the Excel files as data frames, data1 and data2. And want to print the data, we are going to use head. We are going to use head to print the heading or the very first few lines of the data. So read underscore Excel is the function and read Excel is the package that we are going to use. Now so this is how it will look like. We are getting a 6 into 6 and a 6 into 6 triple. That means the 6 row and 6 columns are going to be shown to us. This is how it will look like. These are our data. This is our data from Excel file that is saved as a data frame in R. Now we will understand how we can connect database MySQL with R. See, you can connect databases with R like MySQL, Oracle, like any type of databases you want. But currently for the simplicity, because most of the people have only worked with MySQL, we are going to connect it with MySQL. That is very easy. You just need to install a package. Same like Excel where we needed to install read Excel package. Here we want to install R MySQL package. That is a very small package. It's a built-in package in R, and what it does, it provides connectivity. between R and MySQL databases. For other databases, you might have other packages as well. So what you can do, you can install it using install.packages and inside quotations R MySQL, and your package will be installed. And what else you need to do? You need to use this library function to load the package in your R GUI. How it will work? See, R requires this package to create a connection with object, and what it does, it is going to take username, password, host name, and all the other information. We are going to use this function named dbconnect, which will use to create the connection between the objects in R and the database. This is the syntax. Syntax is dbconnect, that where this is the database driver, this is the username, this is password, this is database name, this is host. The host represents the host name. Here you can clearly see the parameters we are using: database driver, username, password value, database name, and the host name. Let's see with an example how we are actually going to do that. Again, I am expecting if you have a connection, if you have a database already in MySQL, you can definitely use that to install. You can install packages using installer packages or MySQL. Import the library using the library, import it all using the library function, and you are going to use it for your own database connection. Try this. MySQL con, this is the variable where we are saving the connection, and dbconnect is the function that we are going to use. MySQL, this is the name of our database. This is the database driver, which is MySQL. Our username is root. We are importing it from the root username. Password is welcome. You need to know password to your database for it to connect with R. Now database name is GFG. The database that we have created is GFG, and host is localhost. Host is where we are hosting our database. Now in this example, the user is using localhost to host a database into the web server. So we are using localhost. And this is how we will see db list tables. This is again a function that is available in our MySQL package. This will show the tables that are present in the database. As it is written, output will be the table present in the database. If your database has multiple tables, multiple relational tables connected to each other, it is going to show multiple tables. If it has one table, you will get one table. Now this is a little bit of theory that you need to know. In our programming language, a number of data sets are passed to the functions to visualize them using statistical computing. So rather than creating data sets again and again in the console, we can pass those normalized data sets from relational databases. That is exactly what we discussed earlier, that you don't want to create multiple data frames again and again. You want a prepared data already in your system or somewhere. You can import that using few libraries or few functions that are present in a few libraries, be it Excel, be it a database, be it a CSV file, and after importing them, we are going to visualize them, manipulate them, analyze them, and get some information out of them. So R can be connected to many relational databases. Mind it, we are talking about only relational databases that has tables, rows and columns. We cannot use another type of databases like tree or graph or any other. It should be a relational database because R works with relational databases. Remember it as R. Relational stands for R and R stands for relational. And it can connect to other databases like Oracle, MySQL, SQL Server, etc. And the result is a data frame. Result is always going to be a data frame. You import a CSV file, it is going to be a data frame. Be it an Excel file, again a data frame. Be it a database, tables and relational databases, it's again going to be saved as a data frame. So any information, any outside information you are going to import that is present in as a table out there is going to save in your R language as a data frame. And once the result set is fetched into the data frame, it becomes very easy to visualize and manipulate them, that we have just learned how we can manipulate them using select, filter, and summarize and other functions, and how we can visualize them using ggplot too. Let's move forward. So again, we have understood what tidyverse package is before. We have seen that. We know that dplyr package is inside tidyverse package. So either you can install dplyr or tidyverse. Now tidyverse package also has this readr and readxl for enhanced data reading capabilities. So you don't need to install readr and readxl packages already, because they're going to be inside this tidyverse package. Okay, so read csv and readxl are great, but you can also use that includes readr and readxl, so you can have more enhanced functionality for reading data. That is what is written here. You can use library readxl to load the libraries, and data underscore gfg, that is the variable, readxl, that is the function that is already available over there, and data underscore gfg.xlsx, that is we are importing an excel file right here under quotations. What we are trying to say is you don't need to install packages one by one like dplyr, ggplot, then this and that. You can just install tidyverse package, and it's going to have this all packages inside it already. So this is going to provide you more enhanced functionality for reading data. Let's move forward and understand more about data, like statistical analysis of data. See, with data imported and manipulated, it's time to dive into some statistical analysis. So there are two types. Descriptive statistics gives us a snapshot of our data. We can calculate measures like mean, median, mode, standard deviation to understand central tendencies and variability within our dataset. So we have statistical analysis. Now we want to get some insights from data. We want to get some information out of those data. The basic very information that we know are what mean, median, mode, standard deviation, etc. We are going to use those only right now. We are going to use them and understand how they actually function. So imagine you have exam scores. Picture you are analyzing some exam scores. We are going to use this example for all the analyzation that we are going to do here, for all the analysis we are going to perform here. So you want to know what's common, like what's typical, and how to spread out these scores are. So let's see. We are using mean. We are using mean. That mean, what does mean? Adds up the score and divides it by how many are there. It's like finding the very average score. Then we have median. What median does? It imagine arranging the scores in an order. In the order, be it ascending or descending, the scores, the very middle score that is going to be there is going to be median. These are the basic mathematics that we already know. We are going to use the mean function to find the mean. We are going to use the median function, find the median. Then for mode, obviously, what score is the one that appears the most? That's the mode. Sometimes it's none, or sometimes it's even more than one. So sometimes you can get like no mode because every score is different. They are all one. So you have none. And sometimes you have more than one, like every score is going to be multiple times appearing equally, so that is going to be the mode. So you use as numeric, you are going to save it as numeric. You're using the names function right here, and maximum of those table scores. This is a function definition that you need to remember for mode, because If you're going to create it by yourself every time you are going to have issues, you can just practice them a few times and you will remember them very easily. Then we have standard deviation. Obviously, this shows us how far the scores are from the average, like how far they are from what the average should be. The higher it is, the more spread out the scores are. That is what standard deviation is. So standard deviation is going to be like that. We use SD, small case SD as function to know the standard deviation. So this is how the basic statistical analysis is done: mean, median, mode, and standard deviation. The output would be very simple. Mean would be 87.2, median would be 88.5, mode is 85, and standard deviation is 5.83. So our data is spread out 5.83 of the level. Dispersion, that is what deviation is. It tells us how spread out the data is. So standard deviation is one of the most important statistical analysis topic that we use. Like whenever you get some sort of data, you first find mean, median, mode, and standard deviation of that data. So we got the information, the very basic analysis information right here, and this all measures gives us a very clear picture of the scores, how the scores is spread out, what is the mean, what is the median, what is the mode. Let's go more deep into statistical analysis. Let's understand about linear regression. So imagine you have data that seems connected, like how much you spend on advertising and how much you sell. We use simple linear regression to unravel these connections. So like linear regression is one of the mathematical topics that you already have been through. So linear regression aims to find a linear relationship between two variables. So we have, for example, defined two variables, sales and advertising, and we want to predict sales. We want to predict the dependent variable based on an independent variable. How we are going to do that? So we have this function named lm. The function named lm is going to do that for us. It is going to find the linear regression for us. So what we can understand out of it is, think of it like drawing a line through data points. We are trying to see if there's a relationship between two things. What two things are here? Sales and advertising. So for example, more advertising dollars might mean more sales. If you are spending more on advertising, you are having more sales. Or we are basically saying, like, can we use one thing to predict another? Can we use sales to predict advertising, or advertising to predict sales? How we are going to know which is based on which? We are going to know using this function lm. Let's see. So imagine we have sales and advertising data that we have seen already. We are using lm function. What it does, the coefficients help us understand this relationship. In our case, every dollar spent on advertising seems to increase the sales by around $10. See, it is written $10 here. That means every dollar spent on advertising seems to increase the sales by around $10. We are literally predicting the future using data. If we are using more on advertising, we are going to have more on sales. This is how basic prediction works, and you are going to use this information for a larger number of data set, for a big data set. This was just an example or a snippet of how big and how large level of analysis, or let's say statistical analysis, you can do on some data set provided to you. Let's understand hypothesis testing. So, fellow detectives, let's talk about solving data mysteries. Imagine you have two groups, like a control group and a treatment group. Like we have defined here, there's one control group, there's one treatment group. What are we going to do? We are trying to find if they are really different. We are wondering, let's say we are wondering they are very different. So what hypothesis testing actually is think of it like having a theory and gathering evidence to see if it's true. Like This is some detective work, we can say. You have a theory and you want to gather evidence to prove the world that it is true. In the data world, we call it hypothesis testing. In real world, you can say we are Sherlock Holmes or something, but in data world, we call it hypothesis testing. We are asking, literally, is this difference we see real, or could it be just random? The written here is a hypothesis is a statement about a population parameter, and hypothesis testing assesses if there's enough evidence to support or reject a hypothesis. So if we are going to find some proof that both of them are related or similar, we are saying that our hypothesis testing turned out to be true. Or if we find that both of them are not at all connected, not at all real, they are just random, then okay, the hypothesis testing turned out to be false. Let's see how it works. We are conducting a t-test using the function named t-test and saving it. Okay, so now as you have dipped your toes into the world of R and data science, let's talk about what's next. You have got your coding wings and it's time to soar even higher. So, the popular R packages we have right now are tdyr, string R, lubridate. These are the beyond what we have covered. Beyond what we have covered, R offers a treasure trove of packages. Like R have many packages, many. And for data tidying, there's tdyr, this string gr for to take care of string manipulation. You don't need to create functions for string manipulation. You have them already in this package. Then you have lubricate. What it does, lubricate does the simplifies the working with date and time data. You don't need to import or do any other thing. You just need to import this lubricate package and you can work easily with data and time data. You have many functions available there. These are just a few gems in our universe. Yes, so we have tdyr that helps you tidy up the messy data, reshape it, reform it in a structured format. We have string ar that does the manipulation of the strings. You can find, you can change, you can do a lot of string manipulation, you can extract amazing information. Then you have lubricate that eases your way through dates and times. So now that you have seen all that, R is a vast land with many exciting corners. So learning resources are the ones that you are going to need in upcoming time. So your journey should never stop. We have incredible sources to help you learn and grow. You can go for R documentation like official R website. This should be your trusty companion. If you're anytime not sure, just go to R documentation, the official R website. You can get the official documentation about R. Then you have some online courses and platforms like Project Pro. You can create projects. You have Coursera, DataCamp, and many other structured courses where you can learn about them. You have forums like Stack Overflow. Like Stack Overflow is one of the most famous forums out there. You can join R's forums over there, ask questions, get answers. You can join our communities over Reddit and LinkedIn because collaboration breeds growth. So you can use all these resources, all these methods, methodologies to improve your information about R, to know more how you can access data, manipulate them, visualize them, analyze them. You can do much more with them. And using R, it is even more interesting. So these are the resources you can use. Now let's learn about Project Pro because this is how you are going to actually practice, because practice is a true path to mastery. We all know that. So Project Pro is or should be your playground. How? Project Pro gives you real world challenges, hands-on learning and feedback improvement. You are going to get all these things under Project Pro with no problems. Using Project Pro, you will face some real data problems. You are going to get to work on exciting projects, and you can also share your solutions to community of fellow learners. You can do all of that on Project Pro. You can literally, like, hands-on learning. This is not just about reading or watching a video. You are doing it properly. We are taking challenges and mimic them in real life or real life scenarios. Then you are going to work with large number of data sets. You will draw insights out of them. You are going to analyze them, all with having loads of fun. Then you have community and collaboration. Best part about Project Pro, you have a community. Project Pro is a community. You will find others who share your passion, and you will celebrate each other's success. You can discuss approaches, you can share insights, you can learn from different diverse perspectives. Feedback and growth are one thing as well. You are going to remember every challenge you conquer, and you will receive much more better feedbacks from professionals, from other fellow students like yours, and you are definitely going to improve. These are all the perks of using Project Pro for creating and working with amazing real life working and needed projects, and on R you have plenty of them. This is how it will look like. Just go to Project Pro, search about projects in R, and you will get multiple projects out there. For a beginner level to a level of expertise, you will have it all. More than 40, 100, like multiple projects are out there. And if you don't want to, you just want to try it out, you can get a free demo of a project right here. We have multiple data and multiple data sets and multiple projects out there which you can use. Even if you're a beginner, it's going to be very improving for you. So, as a conclusion, we have explored the history and relevance of R, your tool for turning data into insights. We set up R and RStudio playgrounds where coding magic happens. We have delved into R data types, we have done manipulation, visualization, and even some basic statistics like mean, median, mode, and standard deviation. We have also done linear regression in the process. Then we learned to use the deep layer to transform data, ggplot2 to visualize it. We impressed the power of piping to make our code flow like a story. This was all interesting. So remember, this is just the beginning. This is the very beginning. Your journey should not stop. As you move forward, you should keep exploring, you should keep experimenting and apply your skills, because the world of data is vast and R as a language should be your guide. And as speaking of applying your skills, don't forget about Project Pro. It's not just a learning platform, it's your gateway to real world challenges. You can apply it for multiple challenges. You can go for community collaborations. You will definitely grow over there. So keep coding, keep exploring, and keep discovering the magic of turning data into knowledge, and your journey has just begun, and the world of data science is yours to conquer. Keep exploring, keep experimenting, keep innovating. Happy coding. Thank you.